Go ahead, think it through. You should have at least four combinations, and that's the best way to understand these truth tables with just the obvious combinations, I guess. So in programming, we have true, false statements, which basically define Boolean expressions. We have two statements that can both be true, or with coins, they can both be tails, or we can have true or false. With coins, that can be tails or heads. Does it apply? Does it help, or would it count if it was the other way around, where it was false and true? Or in other words, heads and tails? Yeah, of course. There are two coins after all. And what if we have two false statements? What does that mean? Well, it means both coins will be heads. But that's not what truth tables are entirely, is it? There's gotta be more, right? It can't just be these two. You're correct. You're absolutely correct. Because sometimes we can have the not situation where all entries in the P column are the opposite in the not column. So if you have heads in the first row or tails in the first row, what's the opposite of that? It's gonna be heads or false. No, does it work? Does the same logic apply for, well, second row? And yeah, of course. And it works both ways. The phone goes both ways. That's how the saying goes. Definitely not in this context, but you should be able to get the point. And wow, it wasn't that bad. The not before the P just means the opposite of wherever the original column was. Okay, we got that down. Let's apply that logic to Q. Go ahead, pause the video and put in your entries. You should be able to get this false, true, because those are the opposite of the entries in the original Q column. Now, these columns, they only deal with a single variable. But what if we have a column that involves inspecting both variables, where we have P or Q? And in this context, what it's basically saying, if there's a true variable or a true output in either P or Q, the whole output for the P or Q column will be true. So let's look at P or Q. In the first row, in the first two columns, do we have true in either of them? Yeah, we do. And what if in the second row, for instance, there's one false value? Remember, this is P or Q. We're basically performing a short circuit evaluation, and it's just going to create true as an output. Now, what if it was the other way around? It'd be the same as before in the second row. True. And if they're both false in either P or Q, final output is going to be false. Now, in English, our teachers put an emphasis on ands and ors. In fact, your professors may put an emphasis on them in your syllabus. And we did ors in the last column. Now let's do ands. There has to be a true value in P and Q. Otherwise, the whole or the output for the P and Q expression is false. So let's look at the first row of the P and Q column. They're both true, so it's going to be true. In the second row, there's one false value in the Q column, so the whole thing is going to be false. And the third row is just the opposite of the second row, so it's going to be false. And look at this. We have two false entries in the fourth row of the first two columns, so they're going to be false. It's not so crazy now, is it? Now here's where things get a little sinister, right? And this is where we are introduced to these if statements. if P then Q. What? What does that even mean? To put it simply, right? Let this marinate. And if there is a true value in P, that means you have to do further analysis in the Q column. If there is a true value in the Q column, then the whole if expression or statement is true. But what if there's an F in the P column? That means you get to clock out early because you don't have to do any further work and you can go your merry way. And resultantly, that creates an output of true for the if statement because you don't have to do any more work. Now, let's actually walk the walk, yeah? So we're comparing P and Q. In the first row of the first two columns, there's a true value in P. So we had to do further work. Is there a T in Q in the first row? Yeah, absolutely. So the whole thing's going to be true. And the second row is similar to the first row, except when you do further work, there is an F value in the second row for the Q column. As a result, it's going to be false for the whole if statement. And for the last two, let's kill two birds with one stone with this one, okay? They are both false. And because they were false, do you have to do any work? No, you don't. And because you don't have to do any work, it's going to be true for both. It's going to be true for both rows for the if statement. Okay. Now, if you didn't get that one, that's okay. We're going to go. This is more like going through the motions. And in fact, we use the throttle bit and go back to another or statement, not P or Q. Is there a true value in not P or Q? And visually, we're only comparing two columns to fill in that one column. So let's begin. Yeah. Is there a true value in the first row of not P and Q columns? Yeah. Oops. Yeah. Okay. Let's look at the second row of the Q and not P columns. Is it? What? Well, what? I mean, look, they're both false. And what does that mean? It's going to be false for that statement, for the not P or Q statement. Okay. And third row of the Q and not P column, they're both true. So it's going to be true. And the fourth row of the Q and P column is the opposite of the first row in the same column. So it's going to be true. Okay, okay. It's not bad now, is it? Walking down memory lane, right? Except we're going to do one more. One more column to fill. And we're going to focus on the not P and not Q columns. And we're going to do another if statement. If not Q, then not P. So, do we remember what I had discussed earlier? If you didn't, that's okay. If you did, you can skip a few seconds ahead, and or you can just solve for yourself or follow along. So, if there is no true output in not Q, that means you can clock out and you're not doing your work. As a result, the final output is going to be true for the if statement. Otherwise, if there is a true and not Q, you have to step in even further and see if there is a true and not P. If there is, that means the whole if statement is true. Otherwise, it's going to be false. So let's begin, shall we? Here we have true. Why exactly? Well, because it's false in the first row for the not Q column. So we don't do any more work. In fact, we can probably apply the same logic to the third row, where it's also true. Since the false statement saves us on time and spares us the additional deliberation. Now let's look at the second row. There, it's true for not Q in the second and fourth row. As a result, we gotta step in even further. For the second row, because there's a false value for not P, the entire if statement is going to be false. Does the same apply to the fourth row? No. Why? Go ahead and put that in the comments. No. If you understand it, that's great. We'll be going through one more example. Except this one is more out of the books. Where we have this right here. Holy Mother of God. What does it even mean? What? What does this mean in English? Well, it just means Q exclusively if not P or Q. Meaning both sides of this system have to be the same. And where do we start? Man, well, let's go back to the two coin analogy, the two coins analogy, right? How many combinations can you have with two coins? Come on, come on. Four. Yeah, yeah. They can both be heads, they can be heads or tails, or vice versa, or they can both be tails. Okay, okay. Now, we have to create a column for not P and a column for not Q. And let's do it, right? So not P. What is the opposite of true? False. What is the opposite of false? True. So we can fill out these, but remember, we gotta do the same with this as well for not Q. So we have not Q, and by the way, this example is going to be case insensitive. So uppercase P is the same as lowercase p, and the same applies to Q. So let's look at the Q column. All entries in the Q column are going to be the opposite. So false, true, false, true. Alright, well, are we done yet? How much further do we have to go? Well, we have to create a column for this as well, right? In order for us to see if Q is exclusively P, not P or not Q, we gotta hone in on the whole entirety of the right side of the system. So let's do that. And let's see here. We have false for not P in the first row, and false for not Q in the first row as well. What does that mean? It's gonna be false. Because, well, they're both false, and neither of them have the true value. Okay? So let's go down one more row. We have false for not P and true for not Q. Well, we have true in one of them, so there's our answer for the second row. Let's go down another row. We have true, and then we have false. That's going to be true. Alright, one more row. True and true. So that's going to be true. Are we done yet? Come on. How much further do we have to go? Well, we had to consider Q, the left side of the system. The whole enchilada. Ooh, okay. So we gotta compare Q to, which is right here, which is true in the first row, and we already have the whole right side of the system, and it's false for the first row. And because they're not equal to each other, it's gonna be false. Okay, let's go down the second row. We have false and true. Therefore, it's gonna be false. Going down to the third row, we have true and true for both comparisons, and as a result, it's gonna be true. Final boss moment, alright? We have false in the Q column, the fourth row, and we have true in the fourth column For the right side of the system, what's it going to be? What's it going to be? Yeah, it's going to be false. So this is like surface level discrete mathematics, and it's going to help you a lot when it comes to evaluating certain discrete mathematics problems, as well as creating data structures in your computer science course. Anyways, I hope this was helpful. Leave any comments for suggestions, criticisms, or further questions to clear up your confusion. Good night, guys.